Good morning, children. Today we are going to discuss another important topic of surface area and volume. That's the volume part, okay? We have already completed the surface area. Volume of combination of solid. Now, firstly, before moving ahead, we will just see what are the formulas for the volume. I would request with you, please make sure that you know all this formula. Volume of a cone 1 by 3 pi r square h. R is the radius, h is the height. Volume of a hemisphere, that is the half part of a sphere, 2 by 3 pi r cube. Volume of a cylinder, pi r square h. Volume of a cuboid, lbh. Volume of a sphere, 4 by 3 pi r cube. Clear? Now hemisphere means divided by 2, therefore we are getting 2 by 3 pi r cube. Clear? This formula is very much important. You need to make sure that you know all these formulas. Now, when you talk about volume of combination of solid, diagrams are specifically similar to that of surface area. For example, let's say this is the hemisphere. On the top of the hemisphere, a conical block is surmounted. Now, I could see two things. This is a cone and this is the hemisphere. Now, only the difference here is we are talking about the volume. And what is the volume? Volume is the capacity or the ability of a particular structure to hold anything. For example, how much gram a cone ice cream it can hold. Okay? Or next we have cylinder. This is let's say this is a cylinder. A cone is surmounted. This is volume of the cone plus volume of the cylinder. How many liters it hold in this particular cylinder? Next we have, let's say, you might have seen this type of structure. What is this? This is a cylinder and these are two cones. Now what will be the total volume of this particular structure? Volume of two cone plus volume of the cylinder. Clear? Very simple concept. Next we have seen water tanker was there, na? What? Cylinder and these are hemisphere. These are combination of solids. This is also a hemisphere. And what is the structure of this particular whole solid? This is nothing but volume of the cylinder plus volume of two hemisphere. Clear? This is what we are talking about, the volume of combinations of solid. We will start with exercise 13.1. Exercise 13.1, question number 1. If you see this question, what does this question says? A solid is in the shape of a cone standing on a hemisphere with both its radii being equal to 1 centimeter. The height of the cone is equal to radius. Find the volume. It's specifically mentioned a hemisphere. A cone is standing on hemisphere. Hemisphere is there, on the top of it, cone is there. Clear? And the height of, radius of the hemisphere is 1 centimeter and the height of the cone is given as 1 centimeter. So we know the formula. So based on the formula, we know what are things required. Height of the conical part, this is the conical part, is radius of the conical part r equal to 1 centimeter. Radius of the conical part r equal to radius of the conical part r equal to 1 centimeter. Hemispherical part r equal to 1 centimeter. Volume of the solid, volume of the conical part plus volume of the hemisphere. Put the formula, get the answer. Very simple. আমি ইয়াত অকল চাব লাগিব ডায়াগ্ৰামটো চোৱাৰ পিছত আমি চাম ফৰ্মুলাটোত কি লাগে, ৰেডিয়াস লাগে, হাইট লাগে, স্লেন্ট হাইট লাগে, কি লাগে আমি চাম. Then we will write it in this particular form. কোনটোক আমি conical part বুলি কওঁ, hemisphere-টোক আমি hemispherical part বুলি কওঁ. Clear? This is what question number 1 says. Any doubt, please let me know. I'm moving little, explaining in this way because these are direct questions. Okay? Next. Russell, an engineering student, was asked to make a model shaped like a cylinder with two cones attached to it, the two ends, by using a thin aluminum sheet. Directly given. It's directly mentions one cylinder and two cones on both the sides. Diagram is set. 12 centimeter is the whole part. 2 centimeter the cone height is given. Now if you see out of 12 centimeter minus 2 centimeter minus 2 centimeter, we will get 8 centimeter is the height of the cylinder. Now what is the total structure? Volume of the air contained in the model is volume of the cylindrical part plus 2 conical part. We get the answer. Clear? This is what we have in question number 2. Question number 3. A gulab jamun syrup was to make 30% of its volume. Find approximately how many syrup would be found in 45 gulab jamun, each shaped like a cylinder with 2 hemispherical ends with length is 5 cm and diameter is 2.8 cm. There are 45 gulab jamun inside this particular structure. Gulab jamun, this is longer gulab jamun, okay? This is not the gold one, round one, okay? Now, so basically if you see, this is what the structure is. We have 2 hemispheres on the both the side and 1 cylinder on middle. So what we need to do? Volume of the cylinder plus volume of the 2 gulab jamun or 2 hemisphere. We will get the volume of the 1 gulab jamun. Once you get the volume of 1 gulab jamun, we will put 45 into this. Then volume of the sugar syrup is 30% of 45 gulab jamun. That is 30% of that particular answer. We will get the answer. Go through it properly. Any doubt, please let me know. Thank you. Please complete till question number 3 today. Thank you.